Hello everyone, this is the second tutorial for Geo-Studio in University of Guelph ENG 3670. We have this previous example, which was the seepage of the water in the earth dam. So right now we want to see what would be the contamination of the water in the left side in the earth dam. So let's go. We need to analyze the Ctran W, and first let's save as what we have with a new name, which is Ctran W. We need to add Ctran W analysis to this SIP analysis. So let's go to key in and analyze, add the Ctran W analysis to the SIP W, add adverse dispersivity, and that's it. For the seepage result, we have to use parent analysis, which was the SIP W we did for the first example. Close, and we want to analyze the contamination in the earth dam after 1000 days. So we have to change the time from second to days. This we have to change the unit of the time, but first we have to check what would be what is the material and the hydraulic conductivity, which is depends on this unit. For example, for the K hydraulic conductivity, we have 1 E minus 7 meter per second. So now if we change the time unit from second to days, what does it change or not? So it would be the question. So let's change the time to days, and okay, go to key in material earth dam, check the hydraulic conductivity unit and the amount of that. Yeah, you can see the amount didn't change at all, but the unit changed, so it means it's lying. We have to change the unit, or at least we have to change the amount. So let's calculate what would be the amount with this new unit. We have to multiply the previous amount to a days long unit, which is 24 hours, multiply 60 minutes, multiply 60 seconds. Yeah, so 0.00864 would be the new amount for this new unit, meter per days. Okay, so now with this correction we will start this Ctran W analysis, and let's go to key in and define the materials. Yeah, let's first change the time from 1 day to 1000 days, because we need to analyze this pollution after 1000 days of the pollution in the left side of the dam. We want to see what will be the pollution effect on earth dam. So let's change it to 1000 days and save. And the next step after the geometry that we have already is the material definition for Ctran W. We have to define the longitude dispersivity and transverse dispersivity. We know from the lecture, actually you have to know that for the middle point in the left side and for this point in the right side, based on the scale in horizontal and vertical, we can estimate the dispersivity amount in horizontal and vertical directions. So for the points at the middle of the points at the left side, we have 12 meter, and for the right side we have 47 meter. So if we subtract these two amounts and multiply that in 0.1, then we will have the estimation of the dispersivity for the longitude, like dispersivity. So the result would be 3.5 for horizontal direction dispersivity. Let's go to key in and insert this amount in the material and longitudinal transpersivity to 3.5. That's it. But for transverse dispersivity we have to change it again. So what we have to do, again, 0.1 multiply the differential amount between these 2 points would be the good estimation for the transverse dispersivity. 4 minus 0 multiply 0.1, it would be the good estimation for the vertical dispersivity or transverse dispersivity. So just let's go to key in, change this in the material definition to 0.1, 0.4, sorry, and for transversivity and longitudinal dispersivity. So now we can close it. We define the material, we have to allocate the material, and that's it. That's all we have to do with the materials. Now save and let's go to the last part, which is the boundary condition. Okay, we have to delete these ones. We want to do this again. Let's start and add the new contamination boundary, which is the upstream pollution. Upstream pollution, and the type is contamination, and the action would be 1 gram per cubic meter of the left side water. The other boundary is the free exit boundary in downstream, and the action would be 0 gram per days, and the QD has to be equal to 0. Let's allocate these boundary conditions to the region. To the left side upstream pollution, and to the right side the free exit boundary in the downstream. Now we have to verify, like every time, and solve the analysis. We have to solve CW and Ctran both now to match them together, and that's it. We can see the post-processor, and this is the result of the contamination in earth dam. You can see how the pollution comes down to the earth dam and polluted the earth dam. So from the left side the pollution came inside the earth dam, and this is how the contamination will go inside the earth dam. Now we can see the potential lines for this pollution from 0.19 to 0. Thank you for your patience.